Hi, I'm Sarah LaSelva. I'm a product marketing manager for the NIRF products. I'm here today to talk about our AI benchmarking testbed. So in this table behind me, we have a full 5G network built up. On my right, this computer is running Open Air Interface UE, so user equipment, which is the handset side. And then to my left, we have a server that's running Open Air Interface GNodeB, or the base station side. And then each one is connected up to a USRP, which are acting as the RF front end. So everything's running in real time over an RF channel, just like a real network would. But what makes this system special is that we actually have two versions of software running on our base station. So the first is standard off-the-shelf OAI, 3GPP compliant, showing just like a 5G network today would. The other version, we pulled out a few pieces of digital signal processing and replaced it with a machine learning model. Now, at NI, we're not machine learning experts, and our goal wasn't to develop a model. So we took an open source model from Nokia called DeepRx and used that. The first step of this project was to train the model. We used our USRPs and our RF data recording API to collect a bunch of data to train that model. We trained it, we validated that our version of the model was performing the same way that Nokia's was in the paper that they published. And then we got to work at putting it inside of our base station. Now, when we did that, in order to meet timing, the timing constraints of 5G network, we had to reduce the size of the model pretty significantly. And to reduce the size of the model means we can use less data to train on. And when we did that, we had some key learnings that came about. And the real big takeaway is that it's hard to get good, broad performance improvements using AI, or at least in this scenario, and with a reduced size model. Now, we could tweak our training data and perform on specific different scenarios, or site-specific scenarios, you might say in the wireless world, to really get good performance gains, but in specific settings. We didn't necessarily see a decrease in improvement across the other settings. We just didn't see as big of gains. And we think this kind of takeaway is really important as people go out in the world and start trying to implement AI inside of their systems. It's important to understand how the AI performs in simulation, but also how it performs inside of a real-world system running in real time, just like it will once it gets out in the world. So we hope that this benchmarking system can be of interest to you as you start to go out and do AI research on your own. Thanks.